I just revise this full adder and the half adder. Now remember, this section is added for the new syllabus. Earlier this was not there. Initially we got the questions from the 2018 and 19 and the last this year paper. We got some questions from this full adder and the half adder. Now basically, what do you mean by this adder? So adder means the device which do the addition. That's what I call the adder. Now here, initially we discussed the half adder. Now this half adder actually which has only two inputs. That is as given in this table. We have the two inputs A and B. This one. So the inputs are these two, A and B. Now since adder does the addition, so we do the addition. When you do the addition, you can see we add them together. 0 plus 0 is 0, and 0 plus 1 is 1, and 1 plus 1 is how much? Sorry, 1 plus 0 is 1. Then 1 plus 1 is 2, but we know 2 means then the 2 divided by 2. You get how much? 1, 0. Then basically 2 means 1, 0. Then you put 0 here, this 0 here. The other one is the one which is written here other side as a carry. So therefore the sum is given by this. When the two numbers are added, sum is given by this. But when you add it, you get the additional value. Here 1 plus 1, 2, 2 means 1, 0. That one is represented here. But here we don't get the additional one, that is why I just put 0 here. That is equal as a carry bit. So then you can see we get the tables for the inputs. Now last week we have discussed when the truth table is given, how to find the Boolean expression. So in that case you can get the Boolean expression either in the SOP or POS. So in this one, now here this is the input, and here this is the output. So to get this output as a sum, we want to find out what's the Boolean expressions for the sum. So then how do you write the Boolean expressions for the sum? So if you can remember, the last week I have explained to you when there is a truth table, how to get the Boolean expressions. So there we discuss how to write the SOP answer and the POS answer. If you can remember, I explained that in the previous class. So like this here, when you have the inputs, these are the inputs and this is the output. Now we want to get the expressions for the output. Then how to get the expression for the output? So here you can see this is 1. 1 is giving the SOP, sum of product. So this is 1, this is another one, this is another one, this is another one. Then how to get the SOP answer? Just multiply A into B into C. A into B into C, just multiply them together. Then here both A and B are 0, therefore you have to put the bar. In this one, this is 0, B is 0, you have to put the bar for the B. Here C is 0, you have to put the bar for the C, and others just write, and then add them together. So add them together, then you get the expressions like this here. So this is what you get. So that's the Boolean expressions you will get in SOP, sum of product. So that represent the output Z. Then you can write Z is equal to this. So then when you have the inputs and outputs, to find the relationship between the inputs and output, we can use SOP and POS, but most probably we are using the SOP, sum of product form. Similarly, you can assume here, this is the input and this is the output. So then sum, you can write the Boolean expression for the sum. So sum will be equal to which one? Then you can see sum should be equal to, here there are two ones. This is one and this another one. There are two ones. There are only two inputs, A and B. So here A is 0 and the other one is B is 0. Therefore, you can write this Boolean expression is equal to A into B plus again A into B. Then you can see first one here A is 0. Therefore, you have to write A bar. A bar. Therefore, this should be A bar. And here B is 0, therefore B bar. Then you can see the Boolean expression sum is given by A bar B plus AB bar. So we know this is equal to which one? This is equal to exclusive O, that is A plus B, where we have to make it circle. This one should be circle like this. Then we write this is equal to which one? This is equal to XO, exclusive O. So the sum is given by exclusive O. That means when the inputs are given A and B, sum is given as this. This is the logic gate for the exclusive O. Is that clear? Can you hear me?
Yes, sir.
Yes, sir.
Okay, that is a sum. Then similarly, we want to calculate the expression for this one. That is also can be done in the similar way. Here there is only this one, only one here. Therefore, for that one, you can write the Boolean expression which is equal to A into B, because here this is for, this one is for these 1 and 1, that is just AB. So therefore this carry bit is given by this multiplication, A into B multiplication. So that is the way you can get the expression for the Halfadder. Okay, then we'll go to the full adder. So basically full adder, the difference is where you get the 3 inputs. Then we'll come to the full adder. Now basically in the full adder what happened, we have the 3 inputs. Sum is just addition actually. We just do the addition. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 2, 2 means 1, 0, put the 0 here, other one go to other side. Now in the full adder, we have the 3 inputs. So then the truth table will be so get the 3 inputs A, B, we write C in, but we just write C here, that is then you have to write the additional value Okay, then we can write the inputs. The initial inputs are 0, 0, 0. When we add them together, we don't get any additional value as a carry bit. Sum will be 0 when you add them together. When the 0, 0, 1, when you add them together, we don't get the additional value here. When you add 0, 0, 1 is just 1 here. Then 0, 1, 0, when you add them 3 together, the answer is additional is 0 and the sum will be equal to 1. 0, 1, 1 addition is 1, 0. And 1, 0, 0 addition will be how much? And when you add them together, 1 plus 1 is 2. 2 means how much? 1, 0. When you add them together, 1 plus 1 is 2. 2 means 1, 0. Then here inputs are 1, 1, 1. When you add them together, answer is 3. 3 means 1 and 1. So this is the table you get. We want to get the expressions. Now you can see for the expressions we can get, we can just take the yeah, it's same as a right Halfadder, but in the Halfadder these two written in the other way order, but here we just write. Now you can see 1 plus 1 plus 2, 2 means 1, 0. Again 2 means 1, 0. Here 1 plus 1 plus 1, 3. 3 means 1, 1. Same thing. There is no difference, but only difference is in Halfadder we had only 2 inputs, but in the full adder we have the 3 inputs. We want to write the
Yes, sir.
Boolean expression for the sum. Now we did just take this sum, this one. So then you can write for the one, you can write A, B, C multiplication. Next one also A, B, C multiplication. This one also A, B, C multiplication. This one also A, B, C multiplications. So we are going to use the SOP form, sum of product form. No, not necessary. You can write in the same order, no matter. There's no difference. Normally we write in the sum, the order we comes in this way, that is 1 plus 1 plus 3 means 1, 1. Here 1 plus 1 is 2, 2 means 1, 0. Therefore writing this will be more accurate. Otherwise you can change the order, no matter. Now we want to write the expression. Then to write the expression, now here first two A and B are 0. Therefore it is A bar and B bar. And next one A is 0. Therefore A bar. And next one C bar, like this. And here B and C are 0. Therefore B bar and C bar. And here all are 1. So then you get the answer equals to, sum is equal to A into B into C plus A into B into C plus A into B into C plus, there are 4 terms, A into B into C. So then so here A bar, B bar, so here there must be bar and there must be a bar. and then the second one A bar C bar, A bar here and C bar here the B bar and C bar. So that is the one you get. We want to find out what is the equivalent expressions for this. So to find out that, what we can do is, we know that earlier we have discussed A exclusive B. A exclusive B, what is a Boolean expression? A exclusive B, remember A exclusive B Boolean expression is equal to, remember A exclusive B Boolean expression is equal to A B bar plus A bar B. That's a Boolean expression. Is it clear?
Yes, sir.
Hello. නෑ sequential access විතරයි. sequential access විතරයි. sequential access දාන්න.
sequential access විතරයි.
ඔව්.
මේ අනිත් එක මේ මගේ සබ්ජෙක්ට් එකේ ගියාම 0 of 22 assumptions කියලා තියෙන ඉතින් එකයි වගේ මේ සිස්ටම් එක ඇඩ් කරලා තියෙනවා. ඒකට නම් හිතියා මට මතක විදියට මට මතක නෑ අර කොහොමද
මේ ඔයා ඒක දාලා පොඩ මටයි දාන්න මේ වසන්තට මැසේජ් එකක් දාන්න ඊමේල් එකක් දාන්න පුළුවන්ද මෙච්චර ඉන්නේ කියලා. ඒතර ඒගොල්ලෝ බලයි.
හරි.
ඒතර වසන්ති බලයි. ඔයාගේ හෙට නෙමෙයි අනිදනේ තියෙන්නේ.
හරි.
ඔව්. මේ ඊමේල් එකක් දාන්න දැන් මම. Now is it clear? A exclusive B expression. Now
Yes,
if
sir.
the A exclusive B this one, if I have B exclusive C, what will be the answer? If I have A exclusive B is this one, what is the expression you get? B exclusive C. What is the expression? B exclusive C should be what? B into C bar plus B bar into C. So according to the previous one, this should be equal to B into C bar multiply B bar into C bar. B bar into C. That is a Boolean expression for B exclusive C. Is that clear? Same pattern. Is it clear?
Yes, sir.
Okay. Now, if I have A exclusive B exclusive C, if I have expressions like this, that is basically we have the A exclusive B and B exclusive C. So what is the answer? Now in this case you have three components, therefore you can't write at once all together. So what we can do is we can just take only one component, like we can take only this one. We can just take this one. So we can just take only B and C as a one term. Now just take this as a one term, B and C as a one term, and A is another term. So then if I have a two terms, you can write B C bar and B bar C. Similarly, you can assume there are only two terms. That is, we have only one is A, exclusive O, and you can consider this the other part B and C separately. That is a B exclusive C. And plus I can write A again, now here I can assume this A is a separate term and these two are separate terms. Then you can write A and B exclusive C is a one term, and we can have that one as it is. So then I can write according to this, if I have AB, I can write AB bar and A bar B. According to that, you can take A is a one term and BC is another term. Then I can write A B exclusive C bar plus A bar and B plus exclusive C separately. Because here you can see, here we write A first and then B bar, and then write A bar and B. Similarly, A first and BC bar plus A bar and the other one. Is it clear?
Yes,
Okay,
sir.
sir.
Yeah, then what we need to do is, then you can write in the next term, this A you can keep as it is, and the B plus C bracket, this one you can expand. Here we know B plus C exclusive O. B plus C exclusive O is this one. You can write that one here. You can write that one here. That is, you can write here A B exclusive C is equal to B into C bar plus B into C bar plus other one we have the A bar, again we have the B exclusive C, that you can write BC B into C plus B into C, this one. Yeah, I'll explain it again. Now here you can consider this is one component, this is one component, this is another component, these two are another component. Then you can write first A and the other one is B exclusive C and then bar, and you can write A bar and the other one. So that is how you write A exclusive B. Now here we write A exclusive B equals to AB bar and A bar B. Same way you can consider A is a one term, BC is another term. Then you can write A BC bar plus A bar just BC. Then this A I am writing here, that A I am writing here, and this one I expand this one. Then you get B C bar and B bar C. And there's another bar here, this one. That bar you write again, this one. And here again B C bar and B bar C. So in the next round, is that clear up to now? Any questions?
Okay. Okay.
Okay, then the next step,
Clear, sir.
yes, sorry. Here there's a bar. Yes, there must be a bar here. Yes, there must be a bar. Okay, then we just take this. A is here, and for we have the BC plus BC plus ABC then you can see when you expand this A bar, when you expand this one, you get A bar BC bar, A bar BC bar. And here when you expand these two, you get A bar B bar C, A bar B bar C. Now what I want to show you that you can see, okay, now we can simplify this one again. A bracket BC plus again BC, and you can expand this, then you get ABC plus ABC. Now here when you take this one, when you expand this, you get A bar BC bar. When you multiply these two, you get, when you multiply these two, get A bar is a one term and C bar is another term. When you multiply these two, you get A bar and B bar and C, this one and this one, that. So you can see this one is equal to this one, and this one is equal to this one. Is that clear? So remember here I just expand this component, that is you get A bar BC bar, A bar BC bar, that is one. Other one is when you expand these two, you get A bar and B bar. Then you can see this one and this one is same, and this one and this one also same. Is that clear? And for the first term, here we have BC
Yes,
bar and B bar C, and there's a bar here, there's a larger bar. So you can apply the De Morgan's law for that one. There's a bar here like this altogether. Now we have proved these two are equal to these two. Then we can apply the De Morgan's law for the first part. So when you apply the De Morgan's law for the first part, you get A bracket BC, addition becomes multiplication. So I don't write the other part because we have proved that other two are equal. Then here we have the BC bar and B bar C. And this bar will be separated. You get a bar here and you get a bar here like this. Then again we can apply the De Morgan's law for that. Then you get A bracket. For the other one again BC bar, again you can apply the De Morgan's law. Then you can write that is equal to B plus C bracket, and other one also we can apply the De Morgan's law, then it becomes B plus C like this. So what happened when you apply the De Morgan's law again? Here B plus C bar, here C bar, and here B bar plus C, this one. And this bar applied again twice, then you get bar here and you get another bar here, and you get bar here, another bar here. No, database we haven't started. Is that clear? This is step.
Yes, sir.
Okay, then if you have questions you can ask. Then A bracket, then you get B plus C, again bracket B plus C. Yeah, for this last step, here we have the A, and we can apply the De Morgan's law for this PC into PC bar. So what happened? Here we have this BC bar and B bar C, we have that. So then we have another bar, so that bar should be separated. It's not clear. A into so now here we have this addition changed to multiplication because of the De Morgan's law. Here this addition changed to multiplication, and the BC bar we can write like this, and B bar C you can write like this, and there's another bar on top. When you apply the De Morgan's, this bar will be separated to each like this. Exactly that is step.
Yes, sir.
Okay, then what you can do is you can apply the De Morgan's law again. Then you get A into bracket, then the multiplication becomes addition. again this multiplication becomes addition. So what happened here, BC bar, this multiplication becomes addition, and this multiplication will be addition, and there's a bar here, this bar will be separated. Then you get B bar and then bar here, and there's a bar here, this should be separated like this. So then what happened, then you get this is equal to sorry, A is there, A B plus C so then you get bar here, B bar, and double bar cancel, here double bar cancel, then C bar. So the next time what we can do is you can expand this B bar into B bar into C bar, C into B, C into C bar. So you get this is equal to A bracket B into B bar plus B into C bar plus C into B plus C into C bar. So then you get B into B bar into B, first one, and B bar into C bar, and then C into B, C into C bar. Then we know B into B bar 0, this is 0, C into C bar is 0, this is 0, because we have the rule complement law, B into B bar 0, C into C bar 0. Then you get the answer A multiply B bar C bar plus BC. Then you get B bar C bar and BC. Then when you expand this is equal to ABC plus ABC. Then what do you get? A B bar C bar and ABC. Then you can see A B bar C bar is this one and ABC is this one. Now what I want to prove is I want to prove this sum. Now this sum is equal to which one? This one. A exclusive, B exclusive, C exclusive. Therefore this sum is equal to, you must remember this sum is equal to which one? A exclusive, B exclusive, C. This is what you should remember. Probably this simplification you don't need to remember, but you must know that the sum of the full ladder is equal to A exclusive, B exclusive, C. Sum of the half adder is A exclusive, B only, but full ladder has 3 inputs, therefore sum is equal to A exclusive, B exclusive, C. Half adder it is only A exclusive, B. Is that clear?
Yes, sir.
So then you must remember sum of the full ladder is equal to A exclusive, B exclusive, C. Half adder it is only just A exclusive, B. That is a sum. So in the exam they don't expect this kind of simplification, but you must know how to do that, how to get that answer. Or you must remember for the full ladder sum is equal to A exclusive, B exclusive, C. Is that clear? Anyone has
Yes.
questions? Is it clear?
Yes, sir.
Yes, sir.
Okay. So you must try to note down and then try to do these things again. Like when you have the time, just do these things again. When you do it, only you familiar with, then only you learn it. So when we are studying, we have done the things again and again several times. So what happened when you do the things again and again, you practice, then you will be able to do everything. Therefore, just listening to the lesson is not enough. Later you can try out this one alone. Just create, okay, half adder is this one, there are two inputs. Full adder means there are three inputs. Full adder inputs sum is coming by adding all this. Then we have the carry bit as additional value, and this is the SOP's form. And then simplify it again. Just try it again. You have to do it again, then only you can learn it. Otherwise, the surface learning is not enough for the A levels. You have to go into it. You have to go into the depth. Surface learning is enough for the O level. Just learning something is enough for the O level to get a A. But sorry, O level, in the O level exams, just the surface learning is enough. Just go through in the whatever the without going the depth. It's okay. But in the A level, you can't do like that. To study something, what you have to do is you have to go into the depth. But for that one, you have to allocate your time and do the work by yourself. So when you do it by yourself, automatically the knowledge will be built in your mind. You can solve the problem very easily. Initially, you can find the difficulties. Any subject, any area, when you are starting, may be very difficult. But once you spend your time alone, you have to study by yourself actually. You have to have some pattern of studying. And again, the doing the work on time is very important without waiting the last minute to study. Regular studying is enough or is needed in the A level. Whatever things we study today, you have to just go through it again today itself, or tomorrow you have to complete it again. And just clear your mind with the difficult parts. So that you have to train your brain. So in that case, after you do some work, what happen, any cases you can solve. That's the ability of this kind of subject actually. Because not like other subject memorizing something, it works. But this kind of technical subject, actually just memorizing is not enough. Because after you go to the university, or after completing your degree wherever, you are going to be a kind of the different person with compared to others actually, because the technical subjects are something like that, where we have to think and do something, not just memorizing doesn't work here actually. Because in future you may be a software engineer, or maybe a software developer, maybe a system analyst, so that kind of, or some security expert, like you are going to have that kind of profession once you complete these programs related to this IT actually. There are a lot of big demands for this IT field. So basically, in this subject, logical thinking is needed actually. That is why we do something bit complex, very difficult things actually. Otherwise, these lessons, remember, we can teach by just explaining the very simple terms without going into the depth. Very simple terms we can explain. Okay, that tut actually SQL was not there. That is only the database introduction. So remember, this subject actually you need to have good knowledge or thinking power is needed. So that is why I'm always trying to explain some difficult parts to you, because then you understand there are difficult things like this. Once you learn those things, very easily you can solve the problems. Otherwise we can do very simple easy thing you can make happy, but that is not actual teaching, because you have to teach alter the difficult parts also, so that you learn the things there. Now here you need to keep in mind, remember this full adder, the sum is given by A exclusive B exclusive C. Then we have to look at the other one, these for the sum, we have completed sum. Then the next one is to look at the expressions for the carry. So now let's see how to get the expressions for that. So now we want to get the expressions for this one. Now I just erase this. Now we have to get the expressions for this. So in that case you get here, this one is ABC and ABC and ABC and ABC. This is what you get. So here now this is 0, therefore you have to have the bar, and this is 0, therefore you have to have the bar, and this is 0, you have to have the bar. Therefore you get the expression equal to ABC 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 and ABC. So you have this, then here we have the A bar, and here have the B bar, and here the C bar. Okay, now for this one, can you use the laws in the Boolean algebra and simplify? Take the two terms together and simplify. Can you do it quickly? Then I'll explain the answer. What is the answer? Simplify it. Yes, actually here the answer, there are two ways to simplify. One way is here, what we can do is you can take the C out. You can take the C out. If you take the C out, then you get AB plus AB. And here if you take AB out, then you get C plus C bar. Then here you can see you get A bar B and AB bar, and here you get C bar plus C. Then you can see, you can write this is equal to C into what is the other one? We know this is equal to, you can see this is equal to this one, A bar B equal to A exclusive B. Therefore you can write this is equal to C into A exclusive plus AB. Then this one is equal to A exclusive B. This is equal to A exclusive B. So sorry, that is equal to A exclusive B, and this is AB. So then you can write this is equal to C into A exclusive B plus AB. That is one way to simplify. But remember, this can be simplified further if you just take as first one is ABC plus ABC plus AB. So we have this one, we can write here A bar BC and AB bar C, and these two when you simplify, that is equal to AB. So from that one you can take the A out. You can take the A out. A is common. So then you can write this is equal to ABC plus A is common. Take the A out. Then the remaining will be BC plus B. AB, then this one we have to write A bar B, this one, and from this A is common, take the A out, then the remaining will be B bar C plus B. Then remember, for this one we can apply a distributive law. If you can remember the distributive law, this one, A plus BC equal to which one? Two brackets, A plus B, and again the bracket A plus C. So you get same thing here. For this one also you can apply the same rule for this one. Then you can write this is equal to ABC plus A into you can write the expressions, that is B plus B, again C plus B. Then when you apply the distributive law for this one, you get A bar BC, and here B bar plus B is a 1. Other one is B plus C. Then we know B plus B bar is 1. Therefore, next time you get this is equal to ABC plus A into C plus B. Then you get A bar BC A into B plus C. Then you can write it again. This is equal to ABC plus, when you expand this you get AC plus AB. Then you can see here, when you expand this AC and AB, then from these two you have the A bar BC. From these two you can see C is common, take the C out. C is common, just take the C out. So when you take the C out, I just write here, then you get C out, bracket A bar B plus A plus AB. Then you get here C out. When you take the C out, you get A bar B, this one A bar B and A. Now for this one also you can apply the rule, this rule. When you apply the rule, you get this is equal to C A bar plus A B plus A B plus A plus AB. So then you get here A bar here. This A bar plus A is how much? 1. Then you get C into B plus C plus AB. Then when you expand this, you get, when you expand this, you get the BC plus AC plus AB. So then you can see the sum is, or the carry is given by which one? AB multiplication, AC multiplication, BC multiplication, all multiply and add. But for the half adder, we have two inputs, just AB. But full adder, there are three inputs, A, B, C. Therefore, this expressions for the carry is equal to AB plus AC plus BC. All should multiply and do the addition. So that is the Boolean expressions you get for the carry. Is that clear?
Yes, sir.
So then you can see sum is given by A, B, C and just exclusive A, B, C, and the carry is given by AB multiplication, AC multiplication. Now this is A and this is B, AB multiplication and BC multiplication and AC multiplication, all must be added together. So that is given by the carry. Is it clear? So then basically at the end you must remember sum is equal to which one? Sum is equal to A exclusive, B exclusive,
Yes,
C. So then you must remember the sum is given by A exclusive, sum is given by A this is the A and B. So you have to remember sum is given by A exclusive, B exclusive, C, and this is given by AB plus AC plus BC. Or you can write this is equal to another way. Remember we discussed answer A into exclusive B and C and AB. Both answers are correct. Is it clear?
yes.